Hi, Julian. Yeah, well, I don't think anybody would be happy if I reduced the stream quality further. Are you hotspotting? Uh, yes, I think so. Yeah, for now. So nothing is happening for you, John, or okay. All right, let's get back to trying to make a procedural road. Well, let me just give you a quick demo of what's happening there. So there's a prefab called nav tile. This one. So drop that somewhere in the scene. Maybe somewhere off the ground. And run and see what happens. So, like promised, we now have something that generates a windy path in 3D. Whoa. I think that could be a game in itself, some kind of a maze challenge. Hopefully, like starting with this start point in the center, which is like a four-way crossroads. All these points on this road lead back to Rome, or that crossroad. So, how is this happening? Well, let me give you a quick look there. Like I said, the most similar bit of code that you've dealt with so far with this type of approach was during the lab test, the tree tower block. And now we have something which is called the root tile. So let's have a quick compare by content. Let me just, it's kind of tricky to get the sizes right there. So on the right side here you have the tree tower block, on the left side you have the root tile. Is that kind of readable? Okay, so you can see some of the differences. So we got rid of this building profile, we're not using that. We just have a couple of prefabs for tile, a slope up and a slope down. So if I go back to this concept sketch I have in the PowerPoint. So this is the tile, this is the slope up, and this is a slope down. Basically I made prefabs which take care of oops. So I won't be going through every single line of code on this. Oh no. Oh, okay. So we have recursion count. I remained recursion level to recursion count because it makes a little bit more sense. So we start at 0 and we hopefully don't go over 100 in this case. Like in the tree tower we had max level 3, and then I think that changed depending on conditions. I don't remember right now. But we also have a navigation city manager. So that's our new version of the city manager that just works with today's code. There isn't that much different about it really, but so nav city manager is a reference to navigation city manager. We'll use it later. We have an increment, so we're kind of trying to automate and maybe make it a little little handy to do those array indices operations. Okay, so here in initialize, if you look on your screen maybe into this script, you'll see that there is a in initialize we just assign the initial the recursion count, so this will be incremented by the parent that spawns the child. My slope, which tells you whether we're a flat tile or going up or down, so this is going to be an integer, -1, 0, 1, so downward slope, flat or going up. My rotation, because now we need to worry about which direction the slope is facing. Then I added a function called setIncrements, which is kind of a helper function to refactor the code we've been talking about, because depending on the case, depending on the direction we're facing, I'd like to take care of the X, Y, Z. Remember when you were adding those ones or -1s to the current position to be able to build the next block and check the right index. So this is here in this function, because otherwise this bit of code would have to be repeated everywhere, and that would be really nasty. So yeah, feel free to compare this with the tree tower block. Like I won't go into like too much detail with this. I think this is not kind of beside the point. But I think the differences between the two might be interesting for you, and maybe it will reveal maybe a little bit more of the thinking. It's the same approach, just maybe some details might be different because of the rotation of the blocks, and that we have to remember where the road came from. So we kind of continue on the same direction, or sometimes we take a right turn, or sometimes we go up and down. So we need to kind of keep a track on that. That's the main difference there. Okay, one thing I should mention is that if you're working with nav meshes and nav mesh components, so the real-time version, you need this nav mesh surface component. So let's add this to the scene. So actually, it's already been added. So so this component here, we didn't use it before, but now we will. It allows you to select which type of agent it corresponds to. These settings you can change by clicking on the, well, let me just zoom in case this wasn't visible. So I'm now viewing inspector on the nav mesh surface. And I can see that the nav mesh surface component has the humanoid selected, and use geometry has been set as physics colliders. So this is a choice here we have to make. Do we bake our nav mesh based on actual geometry, or do we bake the mesh based on the physics colliders? So, you know, in our case, it makes sense to use the physics colliders because they're simpler. If you decide to use render meshes, remember that those render meshes need to have an import setting read-write enabled. Let me show you that really quick. So here our nav tile is using the tile mesh. I'm going to the nav tile object, the tile mesh that its mesh filter uses, and the tile model. And here you can see that read write enabled is checked. So this one is very important because those meshes need to be read by the mesh maker, basically, to be able to bake the mesh at runtime. Since we use colliders, it's not an issue for us. Just make sure that the prefabs that we're using, so in this case tile, go to prefabs. There is a nav slope up, nav slope down. So for example, the downward slope, please. Open prefab. Am I lying? No, there is a mesh collider. It's a mesh collider based on the same mesh slope. So wouldn't make a huge difference anyway which way we would go. But we need to make sure either we use colliders or we use mesh renderers, and then. Well, you know, if you have complex meshes for rendering and already have colliders for physics, then by all means use the colliders because they're simpler and quicker. But maybe your colliders are actually not accurate enough to bake the mesh. Then you would want to maybe use the original meshes. And the kind of interesting part here is that you can also use layers. So you know, you can maybe have some objects, you can have something on a separate layer which isn't rendered or isn't physics, but or isn't a collider, but is another mesh that can be used for just nav mesh baking. So like, you know, sky's the limit. Okay, so how does this work now? First of all, you have to keep in mind where we run this level procedurally, and you know, it spawns those blocks, and each block has its own start function and starts doing something else and spawning other blocks. We don't exactly know when the process stops. We'd have to like keep it track somehow, maybe register the block somewhere. So it's like a little bit difficult to say when to start the nav mesh baking. So the kind of like the trivial approach would be to wait a little bit and then bake the mesh. So let's do something like that. First, maybe let me just give you a quick quick heads up. So when you have the nav mesh surface, first thing you need to do is call the build nav mesh method. And this will create the necessary data and build the nav mesh. And then if anything changes later on, then you can use this object that was created, nav mesh data, and update nav mesh. So in our case, we only really need the first one. That will do the job for us. Now about the timing and about doing something which is not necessarily done in a render frame, because you know, most of the execution we do is just short calls that do something, and then we continue with rendering, do something in update or whatever. What about those things that like just kind of happen in parallel and we'd like to wait for a little bit? Well, we can use coroutines for that. So I don't know how many of you like worked with multi-threading, where you kind of run concurrent processing in a different thread. Usually brings in a lot of problems because like you have to synchronize threads, and also like in most cases you cannot do most of the things Unity is really meant to do. Coroutines is kind of like a workaround. It allows you to have code which you can kind of stop and wait and resume in next frame. So official blurb here, a coroutine is like a function that has the ability to pause execution and return control to Unity, but then to continue where it left off on the following frame. So this can be very useful for animations, delays. I already showed a little bit of it on the other during the other lecture, I think. So we will definitely need one to make sure that our building is construction is complete before we build the mesh. So here's a kind of an example of a basic coroutine. It's not the only way to do it, and not the best way either necessarily. You need to make sure you include system collections to use coroutines. Is it readable-ish? Okay. So the first thing is we declare here the coroutine. It's called example coroutine. It has type return type enumerator. This marks it as a coroutine. And here it prints something, and then you have this special keyword yield return, and then you can give, for example, seconds. So this will actually stop execution in the coroutine, wait for 5 seconds, and then after the 5 seconds we'll do something else. In the meantime, start function, update function, they do their own thing. We don't care. It just kind of like gets separated out. So let's try it. So let's try it. Let's go into our navigation city control. Navigation city controller. Sorry, not navigation city manager. Zoom. Okay, and let's go to the very end, and before, maybe after the set slot. Okay, let's add the enumerator. And call it timed nav mesh bake. Okay, and oh shit, I don't see the preview now when I'm doing it like this, so okay. Is this safe? So yield return new. This is a little kind of a maybe new construct to some of you, but this yield return is always there for the coroutine, where you want to actually yield execution, and you want to let something else happen, and then you come back to executing this. So it's a little bit like a separate thread of coding. So wait for seconds. And let's make it 3 seconds. It's a float value. So first we'd like to basically let's instantiate this root tile. Sorry, I'm not sure if road prefab. Add start transform, start location. We don't have a variable like this. Oh no, we do. So we already have start location. It's a transform. It's a public field. So we can use that. So I'd like to actually put that block at a pre-specified location, and then we will use this location for something else later on. We'll use it as a goal. So now after that, we assume the road took a couple of seconds to build, maybe 1 second or something, and now we can do our nav mesh bake. And at the moment, this is all we need. Now, this navmesh is a navmesh surface type variable. So this is from one of the navmesh components from this additional package that we had to import into project. And this will allow us to build the navmeshes at runtime. Just to give you a quick look at the declarations in the beginning. So we have our public navmesh surface, navmesh, so you already should have that. You have public transform start location, okay, and also there's a flag, a boolean flag, navmesh ready. In the beginning it's false, so we will use it to communicate later that the navmesh is already completed. So how about we actually add another wait for 3 seconds or whatever, and navmesh ready is true. Yep. Yep, it will generate. It will generate for the blocks that are already in the scene. We can do a quick test on that. That's the whole problem actually, and the beauty as well of the procedure generation. You don't have to worry about it. It just kind of like will spawn itself all over the place. But the drawback is of course that it's maybe not clear when it finishes. So in this case you don't have to worry about it. We did the same thing. We could do the same thing in start menu. Instantiate won't lock execution. So instantiate won't cause us our frame rate to drop suddenly until everything is ready. Instantiate, we just put that single block there, and in the next frame maybe that block will start running its start function, and everything will keep going. So the thing is that each block, operations on each block, the spawning of its child or whatever, they don't take that long. It's just that the execution kind of like might take over many frames if you have a lot of those blocks. Yep. Well, let's experiment. Well, let me. Okay. Does everybody got this bit of code? So I can move on. Just in case it helps. So it's instantiate row prefab start location, yield return new wait for seconds 3, navmesh build navmesh, yield return new wait for seconds 3, navmesh ready equals true. So the sequence of events should make sense, right? First we build the roads, then we build the navmesh based on them, hopefully, and then at the end we set a flag, and we'll use that later on in the game. Yeah. Okay, so now we have to go to Unity methods start, and we'll call our coroutine. Okay, that's one of the ways to invoke a coroutine. So you see in the start menu, in the start method, it initializes the coroutine and then carries on. This doesn't stop execution in start, it just whatever else would be after that would start executing later. So you could even run this in update, but just not every time. You don't need so many coroutines, that would probably break. But okay, can I proceed? Let me save and let's see what happens. One thing we need to make sure is the Nav City Manager actually has a start location assigned to it. Oh, actually, I think I have a... Oh. I must have had an error at some stage in the... Oh, no, I'm just being silly, sorry. So yeah, start location is already assigned in the Nav City Manager. Also, we have the prefab for road, and we have a prefab building which we don't use right now. We have a tile prefab, these are the more important now. Nav slope up, nav slope down. So just to have a look what's there. So it needs to have a reference to the nav mesh surface. So we've created an object in the scene which has this nav mesh surface component. We have a couple of prefabs that we'll be using. Navigation City Manager is a good place to keep it because we don't need to hold a copy everywhere. We just take the instance of the Navigation City Manager and use them wherever we need. Within every tile that needs to spawn a staircase, it will just refer to Navigation City Manager to find the right prefab. And nav mesh ready is false right now, which is fine. And now start location is assigned. So let's remove this nav tile now, because we're gonna spawn it programmatically. And let's see what happens. I'm running it now. Alright, and now if I select nav mesh surface, voila, we have procedurally generated roads with a nav mesh all around it. So this is looking kind of exciting already. Should I give you a few minutes? Is everybody up to speed with this? You need to highlight the nav mesh surface object and then you'll see it. Well, try running again in case it was something with Are you getting any errors? Is the route being generated? Well, run it again and it will be different. Yeah, sure. No. How is everybody else? Any success? Yeah, cool. You should be able, if you highlight the general channel, well, go live button. Do you have a go live? Oh, okay, that might be the settings there. Well, just kind of like to walk through maybe what could be wrong. Let me just go live again. Okay, so 1 sec. The streaming or the... Yeah, okay. Sure, fair enough. Cool stuff. Okay, I'm just having a problem. Okay. Oh, no, for some reason. Okay. Oh, sorry, I was being slow. Okay. So, how can we refine this now? Well, remember we still have some buildings and some city to build. So, this road generation is perfectly compatible with the buildings because it also uses the city mesh array. So the only difference here in this case is that the city array has been expanded to 40 by 40 by 40 just to give us a bit more space to play with. And if you go into the tile script, root tile, and have a look at methods. So this is the root tile script, and in the beginning we convert our position in world space from the block to the array position. So in the previous examples we were adding 7 because we had 15 by 15 by 15. Now in this case we're adding 20 because we have we have more blocks to play with, so we had to shift the center. There's a little bit of funny thing happening here with this slope going downwards because the way the prefab was set up, it kind of like has a default position upward from where it actually sits. That's just a kind of like implementation detail. Don't need to worry about it. I did mention the set increments. So if you go back in time to where you were working on your tree tower block, remember that when you instantiated the child, you had to add vector up times 1 or -1 or whatever. Now this all got kind of wrapped around into inc vector, and it's using inc x, inc y, increment y, and increment z, and these are the ones which are getting updated by set increments function. So this allows you to specify the rotation for the next block and the slope that we're at. So, you know, depending whether in a flat tile or a slope, this will act a little differently. And this is the implementation here. It has a switch statement, so whether you've used them before or not, they have a very kind of like a rigid structure. So you switch on degrees, and in case it's a 0 degrees, so kind of like going forward in this case, then we just go by decrement Z, and then in case it's 90 we decrement X. You get the idea. This is what it's for. So having this function kind of split out outside, it's a little bit what I did there, the example with the Blockly games. Just took it out there to make the code a little bit more manageable, because otherwise we'd have to have this big mess of a code everywhere. So factorization is your friend. Okay, going back to Navigation City Manager, let's create a function that builds a city. And it will have one argument, integer, iterations. It will be of type void, and public. Okay, so that's okay. Yeah, thank you. I don't know what's happening on my screen right now. Okay. Okay, I will thank you. Give me a shout next time as well. Okay, so what I'd like to do is usually we work with some kind of grid. Now I'd just like to randomize it. So let's do for int I equals 0 to I less than iterations. Okay, so just a very run-of-the-mill loop. You can kind of see where it's heading. Remember, the integer version of random range as the second value is exclusive, so if you actually want to have -15 symmetrically, you have to do it like this. Let's do the same thing for Z. It's okay. And then, actually let's work smart, not hard. Yeah, and let's go to our original city controller, city manager, sorry, methods. These two lines for city buildings from city manager, let's just copy them from city manager, okay? Save me an opportunity to make lots of errors, and I just pasted them there. So what's happening? I'm also randomizing the profile of the building, because I'll be using a building, and I'll instantiate building prefab. What's the location now? Well, I'm going to use the random X and random Z that I just created. The quaternion identity is fine. And then it's not a deluxe tower block anymore, it's nav tower block. Okay, I can't keep this whole line in view all the time, so let me know when you've got this bit. We've copied those two lines of codes from the city manager to okay, this should be barely readable there for you, right? Just to know what's going where. Sorry, Oren, I couldn't hear. Okay. Okay. Anybody else needs a minute? Okay. Well, anyway, it's kind of like a very basic randomization there. We go 50 times or whatever, how many iterations we select, we're calling this function, and just place a building at a random location that we've randomized. So this has a few dangers, but we'll talk about it later. The main thing is that we need to change this nav tower, the deluxe tower block, to nav tower block. That's pretty much the same, but I just made it to work with the navigation city manager. It's a different class, so it has to be that. Right. Make sure to save it, and let's actually make sure that we call it. So let's go to our coroutine. And what we would like to happen first. First, we'd like to build the buildings. So we plop 30 buildings in there, then wait for 3 seconds, then we do the roads. The roads should avoid the buildings, or at least destroy themselves around the buildings. Wait for 3 seconds. We build the nav mesh. We wait for 3 seconds, and then we let everybody else know that nav mesh ready. Okay. Okay, can I proceed? It's we're getting there. It's so let's see if it all breaks. Yes. Okay, the buildings are there. The roads are there. Is the nav mesh there? It is. You see what happened? The nav mesh avoids the buildings, so in case we had agents on the floor, they will be avoided. Additionally, the roads are okay. Now this wasn't a super fine example. Maybe we're just a little bit too... wow. Okay, for some reason the generation now is kind of subdued. Maybe it's because of the buildings stopping it. Or maybe I'm just very unlucky. Yeah, I'd say the buildings have something to do with it. So let's make the buildings a bit more sparse. So build city, let's just build 15 buildings. So again, having a function with a parameter allowed us to make the change really quick. Whether that was it or not, well, it's a little bit of a larger city now. And we can see, we don't see any kind of obvious problems. This building is avoiding, the road is avoiding the building, nothing cuts through the buildings. If it does somewhere on your side, that means that I made a bug somewhere. Okay. Alright, so now on to maybe more exciting things. We'd like to start spawning some agents onto this. So, yeah. Yeah, it could happen. I think it's a minor bug possibly because I think it could be. I noticed it later on, but like I think it might be that in some cases the roadblock that's checking. Well, let's see if maybe we can actually fix it right away. So it was in a root tile, and the original. Let's see. Yeah, the original. It's checking a slot and then deleting the parent actually. So this is not what we want to happen. We actually don't want this section there. Because if it if this slot here, if this next location is taken, then this doesn't happen, but the original block still stays there. Now let's see if we have the same problem somewhere else. Yeah, I think so. I think this is basically me overdoing it. We don't actually need to destroy the game object. The only thing that might need to happen is if the original block. Yeah. So please delete those extra else clauses. Leave this one. That's doing something else. And let's try this now. Not sure, do I need to kind of spend time on this? Let's try if this fixes it, and you can maybe go back to it in the video if... Wow. That's gonna be one hell of a nav mesh. However, those buildings are still happy, so we haven't necessarily cut into any buildings. Well, actually I might be lying, but this I think might be because it's possible that the roof is treated differently. No, I wouldn't be too sure now, because this does look like a collision. Okay, I'll revert this change. This is after the increment, so for sure I shouldn't need to worry about this. Well, there could be it could be also a question of timing now if we've changed it so that it's so huge. It might be that some buildings are still building. Oh, by the way, okay, let's see, just a quick check if this is okay. Why would I destroy? Yeah, I really don't think I should. That might be a bit of misconception there. Maybe that's fixing this bug revealed another bug, but well. Let's leave it like this at the moment. Knowing that sometimes the path extinguishes itself too early, I've added this kind of bias using the recursion count. So this is the variable that just gets incremented if you're like a child of a parent, so you get one number larger. So this should go from 0 to maximum 100. Yeah. So here what's happening is I'm subtracting from 100 this recursion count, dividing it by 15. So and then I'm using it for my random range check. So if random is less than 80, then plus corrector. So this means that it becomes more likely in the beginning to move forward and not stop. So what if I like even make it larger? So I'm going to change this value, this 15, to 10. And this is also used later when we select kind of split-offs here. So here it's supposed to be larger than 70 to be able to split off. So I added the corrector to the random. So just trying to prevent this city to be too small, like in some cases, which is what happens because, you know, the initial couple of branches die too early and then the whole thing dies. So this is kind of acceptable. And in this case we definitely don't have this intersection problem that I see in the other case. So let's leave it like this. Maybe that's something that I'm just not understanding at the moment. Okay, is it time for a break? Ten minutes? Okay. So back 5 after 3.